Okay, so this is for the reflections in science teaching between last year and this year. And Dr. Wong, I hope this works for my reflection. It should be better than reading a boring paper. Okay, first of all, we got all kinds of inquiry going on. And actually, some of these pictures were taken at the Perot Museum in Dallas, which I've told you about. It's pretty cool. A lot of it's just inquiry and the fact that you've got to be curious of what all's out there before you're willing to go and investigate it. And so I try to make sure that the kids understand this concept. Next page. Okay. And again, it's all about, with physics and IPC, it's all about playing with objects and see how they're related. You can get your force and your mass, work and distance. If mass goes up, then acceleration is going to go down because the force is always going to be the same, and work equals force times distance. If force goes up, the distance goes down. They increase and decrease by the same proportion because the work doesn't change. So anyway, and it's about getting kids to see this and letting them play with things. It's hands-on. That's how they learn, through doing things hands-on. And again, this was all done at the Perot Museum. So when you come up and teach my class and let me observe you so I can learn how to be a better teacher, I will take you there because it rocks. Okay? But again, and this is what I've stressed so much. Students have to have a background knowledge of vocabulary before they can apply anything, because you can give them toys to play with all day long. You can give them ramps and cars and the weights, and until they're not going to make that connection until that they know that there's some kind of connection that they're aiming for. And if you tell them, if you give them some kind of guided inquiry and you say, okay, so I want y'all to find two situations where the work is the same on this ramp, and I want y'all to change up the forces and the distance, then yes, then they might be able to discover that and make that connection. But they have to have some kind of background knowledge. It either has to be teacher provided or it has to be prior. Okay, the next slide. Okay, again, this is more hands-on dissection. This is what's loved about biology and life science. Dissections. Right here, these lungs and inside internal organs were taken at the Perot Museum. Notice the lungs are black. I'm going to make a deduction that person might not have been a smoker, but they were around some serious smoke, because a healthy set of lungs do not look like that. I've seen worse lungs, but I've seen a lot better too. Okay, down here in the bottom right, we did the dancing raisins. Kids really got into that. We used that to teach them about documenting between observations and just thoughts. They actually had to observe it, and then they had to distinguish between their observations and their inferences. Okay, and then when they did that, they looked at patterns, like why, and what other type of foods do you think might bob up and down? They applied some deductive reasoning there. So anyway, next slide. Okay, again, these were taken from the Perot Museum. I'm telling you, Dr. Wong, it's awesome. When you come up here, I'll take you, and I'll even pay your way. Bottom of an octopus, you've got the suckers there, but it was in a glass casing, and that's why I've got the glare on there. And then I believe this was some kind of a goat, maybe a sheep. I'm not sure which, but anyway, it's been deskinned. They talked to me about how that they processed it so the body didn't rot. It's pretty cool. So, okay, next screen. Okay, some more hands-on up there in the upper right. We got the genetic lottery. Okay, and this is hands-on application. The kids get to spin the thing down at the bottom, the little spinner. You've got the parents' genotypes given. Okay, and you get to make a baby, and depending on the genotypes of the baby. So you get to make the phenotypes based on the genotypes. Okay, so I'm planning on making something like this. But I use this to show the example of how can I get a baby dragon with purple wings when mama has green wings and daddy has green wings. And wings were actually represented by the B allele. And so, if you have two recessive alleles, if mama gives her little b and daddy gives his little b, then baby's going to get little b, which will be homozygous recessive, which would be for purple wings. So it's kind of neat. And in the bottom left corner, that's actually part of my capstone project. It's the Jello experiment, and I used this early on in the year to help kids figure out not about the old type of scientific method, but just scientific investigation processes. They have to know control group, they have to know independent variable, dependent variable. But in this was a pretty wicked experiment. The kids, we had holes and they were all punched by a straw, so they were all the same size, and it was Jello, all the same type of Jello. If you notice, the one labeled A is the control. That's where I put distilled water. Okay, in B was one type of detergent. The yellow was C, and it was another type of detergent. The red on the bottom was another type of detergent, and the one on the right was the other type of detergent. And through all of this, how come one detergent makes a bigger hole than the others, and definitely bigger than the control group? Well, in seventh grade, we really don't talk about enzymes that are present in, I'm talking about enzymes, period. But I kind of explained to them about enzymes being present in laundry detergents, and that's what helps break down the germs and stuff. And so, but as you can tell on this experiment, the yellow detergent worked far better than the green or the red, and E did pretty good. But anyway, it was an awesome experiment for the kids. They loved it. And the last slide. Okay, again, this was all at the Perot Museum. Cannot leave out my favorite planet, Mr. Uranus. And I still feel for Pluto because he's been excluded from the group. But over here on the right, you've got a little contraption. You put the ball in the little ramp, and it works its way down, and then it goes on the ramp, and it knocks down those things that are the blocks that are standing still, and it's just a chain reaction. It's kind of Newton's laws, talking about potential and kinetic energy and the transfer of the energy between. But anyway, this is kind of what I've learned this over the course of this last year and a half, and I'm working on getting better as a science teacher every day. So anyway, I hope you enjoyed the video.
Hello, Dr. Wong. I did not want you to have to read another of my boring papers that go on forever. I thought that this could be fun. Hope it will suffice for my reflection.
Well, Leslie, I am sure this will be great. You are awesome. More awesome than you can imagine. I have had fun working with you over the past 15 months.
On teacher content knowledge, I will give myself a 3. I feel that even though I might not be the best science teacher out there, I know biology and I know life science. I know that I was a much better math teacher, and that is my passion. But I am learning how to teach science. I know about how kids learn, and how I need to help them make connections.
Ah, Leslie, you are making learning relevant to the students' lives. This is constructivism. That is music to my ears. I am so proud of you.
Thanks. I'm using more inquiry in class and letting them discover for themselves when I can. But sometimes they just have to be given the facts. I haven't become a master at this yet.
Okay, Leslie, how do you feel that you do on student anticipation of understanding and misconceptions? I feel you do a good job of knowing your kids and anticipating their screw-ups.
I learn lots from teaching my first class of the day. I see where kids get confused, so I'm a much better teacher as the day goes on. I also reflect on what I remember didn't work last year. Even though I cannot plan for what kids know or don't know, I put effort into thinking ahead about what might be problematic, simply because I am new to teaching science, and I have so much more to learn. I will give myself a 2 on anticipating student issues and misconceptions.
Great. How do you think you fare on integration? I know each time I listen to you teach, I always hear some connections to other disciplines. I think you make a valiant effort to do this.
I couldn't agree more, Dr. Wong. Thanks for the compliment. I always look to make math connections, and I occasionally make ELA connections. I will give myself a 3 here. What was videotaped did not lend itself to connections. But I constantly make those connections in class. I believe that this reinforces those other subjects and helps students learn.
Okay, The next component is the repertoire of strategies and materials. I would consider this to be one of your weaknesses only because you're new to teaching science. If I were evaluating your math teaching, I am sure that this would be off the chart. I feel that this will come, as you better learn how to teach science.
I suck at teaching science. It is so hard to have students apply on a daily basis. Before they can apply knowledge, they have to obtain that knowledge. I have learned about inquiry. If I were teaching IPC, I feel that I would be much more successful in teaching. But in biology, the rules change all of the time. It is very frustrating. It just seems like the other subjects don't change, and science changes daily. How am I supposed to keep up with the changes? The people in charge of science curriculum at the state level appear to be idiots. We are adopting textbooks this year that will have to last for 10 years. But the state is redoing curriculum in 2016. Stupid. I will give myself a 2 because I'm better than a 1. I incorporate lots of different strategies for learning: computers, games, matching cards, puzzles, conductivity testers, and more. I usually allow the students to partner up with whomever they choose. On any given day, they may sit wherever they like. I do not assign seats until behavior is an issue. I do not teach pre-AP classes, but I have an understanding worked out with some of my more smart kids to always include the lower kids and their groups. Nobody ever works alone.
Okay, Leslie, from your notes here, I see that you give yourself a 1 on differentiation. That really surprises me. The notes say that all of your students are either on or below level?
It really depends on how you define differentiate. I always accommodate and assist all students, regardless of any papers. I do what is best for my students, but I do not have various tasks going on at the same time. I cannot multitask, and it bothers me tremendously to have many different activities going on at one time. I keep kids on the same page. Thanks, Dr. Wong, for coming down here with me. I needed to get out and get some fresh air. I guess we can continue talking about my questioning strategies. I give myself a 3.
I see your point. You do a great job of asking questions that make kids think. The longer you teach science, the easier the questioning will be, and the better you will become. Right now you are still kind of green at this. Don't worry, you will learn in time. Many of your questions require higher order thinking skills. Benny Bloom would be happy. You provide great wait time for your kids when questioning them. You do a wonderful job of helping students answer questions by leading them step by step in their thoughts. Leslie, you really do rock. Kids are lucky to have you for their teacher. You treat all kids like they're special. You are sensitive to their special needs. I wish all teachers had those skills.
Well, thanks, Dr. Wong. I really do value your opinion. From early on in the school year, I emphasize the sense of treating each other with respect. Kids feel safe in my class.
Leslie, I see that you rank yourself a 2 on academic feedback. This includes stating what is expected from the student in terms of student product. You said that you were confused. Why?
Well, because sometimes the objectives we state are not necessarily academic, sometimes they are behavioral, like in a lab. But I still feel that a 2 is a good rank for me. I am better than a 1. I do state the objective each day for my students, and I clearly explain what my expectations are when we are doing any kind of work. However, I do not do a very good job of consistently letting my kids know whether or not they met their objective. Half the time, I am not sure I even know what the objective is. The only time I make sure that they know if they met their standards or objectives is on formal assessments. I need to work on that.
That's awesome, Leslie, that you are picking up on this. You might have some work to do, but at least you realize it. How do you feel you do on student engagement and communication?
I think that I will give myself a 4 here. This is definitely one of my strengths. From early on, I make sure that my classroom is comfortable for all kids. This promotes safety. My kids can be very chatty. Sometimes I have to monitor the conversations as they get off topic, but I frequently have to remind them that they are to discuss things about science and not their social lives, but they are engaged. They ask many questions, not always of each other. They, too, ask me questions. I usually answer back with a question. This drives me more crazy than anything else. I sometimes will joke with them that they only get 2 questions for that day, and I ask them if they are sure that they want to use one.
You are right and not always wanting to answer their questions. But it is a compliment that they seek your knowledge. But yes, you should try to encourage them to find answers for themselves. I know that your district has a BYOD policy and you allow students to use their smartphones for research. It's good that they learn to look elsewhere for answers. I praise you on that.
We're almost finished. Let's look at how I judge myself on proficiency of delivery and transitions. I do not feel like I do a wonderful job here. I will rank myself a 2. I never feel like I have enough time, and I know that I lose time due to bad transitions from topic to topic. Sometimes I present info one way, then I realize that it is not effective, so I will go back and try to erase what I said that was confusing or just not good and try to present info a different way. I also do not use notes or outlines when I am lecturing, so I frequently will leave out important info. Even if I teach or discuss from a PowerPoint or a video, I always forget stuff. I must find a way to become more organized.
You know, Leslie, it's really cool that you are seeing this. That is the purpose of this assignment. I'm impressed with your reflecting. And I know that you are seeing how much you have changed in your teaching philosophies. You have definitely made your class more student-centered with an inquiry approach. iSmart has had a positive impact on your teaching.
The last area to discuss is my class being a student-centered classroom. I rank myself a 2 here. But last year it would have definitely been a 1, so growth is evident, as it is in all components. I try to make learning self-directed, but I am relatively new to teaching science. I am still learning how to be an effective teacher. This is a lifelong process. Just as it's a lifelong process for me, it's a lifelong process for the kids too. Before they can question and design a plan to investigate, they first must be curious.
Leslie, you have grown so much this year. I see what you are doing in science, and I cannot imagine what you would be able to accomplish if you were teaching math, which is your passion. But I think that deep down you are starting to enjoy some aspect of teaching science. I promise not to tell anyone, but your passions are obvious, like in the frog dissection and cells unit.
Thanks for everything. You always help me. It's great to know that I have a science friend who is just a phone call away. I owe you much. You helped me through the lowest point last year.